Hi ladies and gentlemen, Ms. Skokin back with the quotient property of square roots. And what you need to remember is that in order to be in proper final form, we cannot have a radical expression in the denominator. That means if we have a radical in the denominator, we need to use some algebraic manipulation to get rid of it, to process it. So you see that in this example, in the box, we're starting out with 5 divided by the square root of 10. We want to get the square root of 10 out of the denominator. So what we do is we multiply by the square root of 10 over the square root of 10. Now we remember anything over itself is equal to 1. So we're really just multiplying by 1. And then we multiply fractions. Numerator times numerator equals numerator, and denominator times denominator equals denominator. So 5 times the square root of 10 is 5 square root 10. Square root of 10 times square root of 10 is the square root of 100, inside times inside. Or we can say the square root of 10 times the square root of 10 is the same as the square root of 10 squared. And this is where the square root and the square are inverses of one another, so they cancel each other out and we end up with a result of 10. 5 times the square root of 10 over 10 right here, and then we recognize that 5 and 10 have a common factor of 5. So 5 goes into 5 once, and 5 goes into 10 twice, and we end up with the square root of 10 over 2 as our final answer. So that we can remember what steps to take, let's write down a flow map. The first thing that we're going to do is multiply both the numerator and denominator by the radical that we have in the denominator. Multiply both the numerator and the denominator by the radical expression in the denominator is the first step. And that is going to lead to the next step, which is simplify radicals as needed. And this can be seen in this step right here. The next thing that we're going to do is write down the very last step in the flow, and that's simplify the fraction as necessary. And that is in this step right here. These are the steps that we're going to continue to follow in the examples that we've got further down on the page. So let's just take a look at those. And we're going to start out by taking the square root of 56 over 45 and splitting it into 2 radicals. Next, we want to do the prime factorization of both 56 and 45. Then we want to rewrite our fraction using our prime factorization. So the square root of 56 becomes the square root of 2 times 2 times 2 times 7, and the square root of 45 becomes the square root of 3 times 3 times 5. Now we're going to look for pairs of numbers underneath the radical to simplify the radicals as needed. So we see 2 2's and we see 2 3's. We know that those numbers can come outside the radical, so the expression can be rewritten as 2 root, and it's going to be whatever's left over, so 2 times 7, which is 14, over 3 comes out, and that's going to be multiplied to the square root of 5. Okay. Now we are ready to multiply the numerator and denominator by the radical expression in the denominator. In this case, in the denominator, our radical expression is the square root of 5, so we're going to be multiplying by square root of 5 over square root of 5. And then we're going to multiply. Inside times inside equals inside. 14 times 5 actually equals 70. So this is going to be 2 times the square root of 70 divided by 3 times the square root of 5 times the square root of 5. Well, we know the square root of 5 times the square root of 5 is equal to the square root of 25, or 5. And That means that we have in the denominator 3 times 5. That's going to give us a final answer of 2 times the square root of 70 over 15. And you're probably thinking that that doesn't actually look like a very simplified answer, but it is. So we multiplied both the numerator and denominator by the radical expression in the denominator. Then we simplified the radicals as needed. And last of all, we would have simplified the fraction, but it wasn't necessary. Okay, we have another example to do. 5 divided by the square root of 108. Let's start by finding the prime factorization of 108. So again, it's an even number, so I'm going to start with 2 and then 54. 54 is also an even number, so that's going to be 2 and 27. And I know 27 is 3 times 9 or 3 cubed. So we're going to rewrite this as 5 divided by the square root of 2 times 2 times 3 times 3 times 3. So once again, we're looking for pairs so that we can simplify first. We have a pair of 2's and we have a pair of 3's. So we're going to have 5 still in the numerator. We're going to have a 2 come out, a 3 come out, and then what's going to stay left over underneath the radical is just the lonely little 3. Okay, that gives us 5 divided by 6 times the square root of 3. Okay, we multiplied, we're ready to, sorry about that, we're ready to multiply the numerator and denominator by the radical that we have in the denominator, and that means we're going to multiply by square root of 3 over square root of 3. That is going to give us in the numerator 5 times the square root of 3, and in the denominator we're going to have 6 times the square root of 3 times the square root of 3, or 6 times 3. That's going to give us 5 root 3 over 18. That is our final answer for this question. Again, you might feel like it can be more simplified, but in this case, we didn't need to simplify the fraction, so that is going to be our final answer. Let's take a look now at another method of rationalizing a denominator when we have a radical in the denominator. You'll notice in this example problem that we still have a radical in the denominator, but it is not alone. Instead of just having the radical or the square root of 7 in the denominator, we have 1 plus the square root of 7 in the denominator. So we need to do things a slightly different way. And what we do this time is we multiply by what's called the conjugate. And I want you to take a look when we have 4 divided by 1 plus the square root of 7. We multiply by, this is 1 plus the square root of 7. We're going to multiply by 1 minus the square root of 7 divided by or over 1 minus the square root of 7. The two expressions that have the same numbers but opposite signs are called conjugates of one another. And when we multiply the numerator, just again refreshing your memory on this, we're going to distribute that 4 to both of the terms. When we multiply the denominators, we're going to need to FOIL these. Okay? And what's going to end up happening is our middle term is going to cancel out, and we're going to, by foiling, it looks a little bit like magic, we're going to get rid of those middle terms, so we're going to have only integers in the denominator, no more radicals, no more irrational numbers in the denominator. We do end up with 1 in the numerator, as you can see, but that's not a problem. Now, in this example that's shown, we don't actually see all of the foiling, but in the example that we do together, I am going to show you the foiling so that you can use it as a guide for when you're working on your practice problems. Let's take a look at example number 5. The first step is to notice what we have in the denominator, and what we have is 2 times the square root of 2 plus 3. That means our conjugate is going to be 2 times the square root of 2 minus 3. And so we're going to multiply by 2 times the square root of 2 minus 3 to both the numerator and the denominator. In the numerator, we're going to distribute, so we're going to end up with 5 times 2 times the square root of 2 minus 5 times 3. I'm going to show all the work here because I want you to be able to follow along and be able to use it as a guide for when you're doing your problems. So let's get on to the denominator. We have 2 terms times 2 terms. That's a binomial times a binomial, which means we're going to FOIL. So I'm going to have 2 times the square root of 2 multiplied by 2 times the square root of 2. That's the first with the first. Next, we're going to have outside with outside. So that's going to be plus 2 times the square root of 2 multiplied by negative 3. Then the inside plus 3 times 2 square root 2. And then last with last is going to be plus 3 times negative 3. Okay. Oop, I forgot my fraction bar. There's my fraction bar. And this is going to be 10 in the numerator, 10 times the square root of 2 minus 15. In the denominator, we're going to have 2 times the square root of 2 times 2 square root 2. That's going to be 2 times 2 is 4. Square root of 2 times square root of 2 is 2. Okay, plus, actually 2 times square root 2 times negative 3 is actually going to give us a minus 6 root 2. And then we've got plus 3 times 2 root 2. That's going to give us plus 6 root 2. So you can see those are the terms that are going to end up, these are going to cancel out because they are additive inverses, which means when we add them together we get 0. And then last of all, we're going to have plus 3 times negative 3, so that gives us a minus 9. And once again, my fraction bar. Okay, so this is, numerator stays the same. There's no way to combine those two numbers. And then the denominator is going to be 8, 2 terms that canceled out, minus 9. Okay, we know that 8 minus 9 is equal to negative 1. And that means we don't really like the way that looks. We're kind of picky about format. So we're going to say that 10 times the square root of 2 divided by negative 1 makes that term negative. And negative 15 divided by negative 1 is going to give us plus 15. And so we're going to rearrange those so it looks like a subtraction problem instead of a leading negative. And that's our final answer for this question. Let's go on to the next example. We see in the denominator we have 3 minus the square root of 6. So we know that we're going to multiply the numerator and denominator both by 3 plus the square root of 6. This time we need to FOIL in both the numerator and denominator. So switch off the video and try to do the FOILing on your own. Turn the video back on when you're ready to check your work. If you did your FOILing correct in your numerator, you're going to end up with 6 plus 2 root 6 plus 3 root 5 plus square root of 30. And none of those can be simplified any further. Divided by 9 minus 6, which is going to be 3. And I know it looks like we should be able to simplify it further, but we can't. We know we can only combine radicals when they are like terms or have the same number underneath the radical symbol. We'll see more about that thought in the next lesson. But for now, that brings us to your practice problems. And you can practice all of these things that we've just learned with the problems starting on the next page. See you back in class.